So in the last section we talked about using past temporal correlations in activity as a way to indirectly activate recommendation strengths that aren't present in current sensory inputs but could be useful. But how relevant is simultaneous activity in the past likely to be once a certain amount of time has passed since that correlated activity? Well, if two columns are active at the same time, and then again immediately afterwards one is active again, it's fairly likely that the other could be useful. But as time passes, if the simultaneous activity doesn't occur again, the probability of relevance gets less, and therefore the probability of indirect activation should decay fairly rapidly with time. On the other hand, if the simultaneous activity involved receptive field expansion, that's generally a stronger indication of possible later relevance. So the probability of indirect activation should decay more slowly. And even if it's just ordinary simultaneous activity, if it happens repeatedly, that makes it more likely that the indirect activation could be useful. So the mutual recommendation strengths in favor of indirect activation may start to decay more slowly as there's more repetitions, or not decay at all. But there's another critical factor. If there's an indirect activation, and shortly afterwards some positive reward feedback, then the recommendation strengths that led to the indirect activation will be strengthened, and their subsequent decay should be slower. So we've identified some additional considerations. The recommendation strength possessed by one column in favor of indirect activation of another column will evolve in various ways. So there's a value in indirect activation of receptive fields, but there are some complications because the circumstances in which a receptive field will be indirectly activated have to be defined by condition detections. Suppose this represents three sequential arrays of columns with sensory inputs coming into the top array. Think about when that column in green will be activated. It'll be activated when its receptive field's detected, represented by a pot of conditions. One condition could be that a combination of columns in the preceding array detect their receptive fields within sensory inputs. Another condition could be if this different set of columns are activated by sensory inputs. So there's going to be a large number of conditions defined by different combinations of columns in that first array that are detecting their receptive fields within current sensory inputs. Then, if enough of those conditions are detected, the green column will detect its receptive field. But if the circumstances are right, the green column should also be indirectly activated. One condition indicating that indirect activation could be appropriate might be some combination of columns in the same array as the green column, and I've colored that combination blue. That could be another condition, and another, but in this case in a higher array. So we want the column to be activated if enough of the red conditions are detected, as a result of receptive field detections by columns in the top array within current sensory inputs, or if enough of the blue conditions are detected, as a result of activation of groups of columns in the same or some other array that have been active in the past at the same time as the green column. But if there was some mix of red and blue conditions activated, both less than the red and less than the blue thresholds, we don't want an activation of the green column. It's not an appropriate sensory situation, but neither is it an appropriate indirect activation situation. So the green column has to have two separate receptive fields, indicating when it will be activated directly and when indirectly. And the conditions defining those fields must be isolated in some way. So we've identified a further consideration. The circumstances in which a module is directly activated must be separated from those in which it's indirectly activated to prevent activation in circumstances that are partly one and partly the other. In addition to using information about past temporal correlations, there may be some other information about relative activity that a system can use. For example, in the illustrated array, columns may be activated directly and other columns may be activated indirectly. And sometimes the same columns may be activated both directly and indirectly. It may be useful to the system to know the degree of overlap between the direct and the indirect populations. And a separate array of receptive fields could be defined in which the groups of columns activated when there was a lot of overlap were different from if there was little or no overlap. Another useful piece of information could be if receptive field detections in one area quite often indirectly activated a significant group of receptive fields in the other area, but not always. A further array could discriminate between these two situations, and we'll discuss the significance of all these possibilities a bit later.